All right, so we're going to talk about section 2, which is talking about exponential functions. And exponential functions are functions that are in the form of an exponent, such as b to the x power. B is called the base, and x is the exponent. So b has to be greater than 0, and it cannot equal 1. So think about this for a second. If you had 1 to some power, 1 to any power is going to be 1. So we eliminate 1 because that's going to give us like the same set of numbers every single time. And b has to be greater than 0 because if we make it negative, our graphs are not going to be the same. So here's some examples of exponential functions. So I have 3 raised to the x power. 3 is my base. 2 raised to the x power. 2 is my base. 1/2 raised to the x power. 1/2 is my base. So to graph these, I'm going to use, just pick some values for my graph. So I'm picking maybe 3 to the 0 power is 1, 3 to the first power is 3. So I'm looking at the ordered pair here, 0, 1, and 1, 3, and 2, 9. And let's do -1, so -1 and 1/3, because remember, if you raise something to a negative power, it becomes the reciprocal. So when I graph these now, so I have 0, 1, and I have 1, 3, and I have 2, 9, which is off the screen, or off the graph. And then I have -1 and 1/3. So you'll notice that you have an increasing curve, okay? You have an asymptote at y equals 0. And you'll notice that it goes through the point 0, 1. Okay, so then we do the same thing for 15 to the x power. So I end up with 0, 1, 1, 15, and -1, I'm sorry, positive 1/15. So again, 0, 1, and then 1 all the way up here at 15, and then -1 at like 1/15. So notice that it is steeper than our original graph. It's much steeper. But again, we still have that asymptote at y equals 0. And then again, we graph the points 2, or the exponential equation 2. So we end up with 0, 1 again, 1, 2, and then -1, 1/2. So again, it's a little bit shallower, not quite as steep. And I end up with my exponential curve again. So the things that you should notice about this: the y-intercepts are 0, 1. So for every single one of these problems, they go through the y-intercept at 0, 1. There is no x-intercept. In fact, we have an asymptote at y equals 0. All of these graphs are increasing. And all of the graphs go through the point 1, b, where b is the base of the exponent. So therefore, if I gave you a problem and I said 4 to the x power, I would know that that's going to go through the point 0, 1 and 1, 4. And so using that information, I could graph my exponential problem. Okay, so now we go on to a little bit different shape. So it's the same types of problems, but notice that the bases are all fractional bases. So I'm still going to have, if I substitute in 0, I'm going to get 1. And if I substitute in 1, I'm going to get 1/2. And this time if I substitute in -1, I'm going to get 2. So I've got 0, 1, 1, 1/2, and -1, 2. And on this one, I'm going to have 0, 1, 1, 1/3, and -1, 3. So you'll notice that all of these graphs are decreasing. Okay, they all again go through 0, 1. They all again go through the point 1b. So we notice that in this case, again, our y-intercepts are 0, 1. There's no x-intercept, but again, I have a y equals 0 asymptote. These are all decreasing graphs, and again, they all go through the point 1b. So when I put all this together, anytime I have an exponential function, I know it's going to go through the point 0, 1, and I know it's going to go through the point 1b. So I know that if the base is bigger than 1, then it's going to be an increasing function. And I know that if the base is a fraction between 0 and 1, then it's going to be a decreasing function. So I can use this information to graph every exponential function I have. So I have 3/4 x, so it's less than 1, so it's going to be decreasing. So I know it's going to go through 0, 1, and I know it's going to go through 1 3/4, okay? And then I can estimate my graph based on that. This one is going to be an increasing function. It's going to go through 0, 1, and 1 6. And so it's going to be an increasing function. This one, be careful. 5/2 is 2.5. So again, I know it's going to be increasing, so it's going to be through 0, 1, and 1 2.5, and it's going to be an increasing function. Okay? So now, if I take that information and I start talking about translating it, so the translations are going to work the same way that they've done before. So for example, this minus c is going to move it up or down. I wrote left. It's going to move it down or up c places. So if it's plus c, it's going to move it up. If it's minus c, it's going to move it down. And this minus c as the exponent is going to move it to the right or to the left, depending on whether it's minus c or plus c. So let's take some of our basic powers here. So we have b to the x power. That's our parent function. It goes through 0, 1, and 1b. Okay? So if I put a plus 1 after that, that means it's going to add 1, and I know that looks like toy. It's going to add 1 to the y value. So that means it's going to add 1 to 1, and it's going to add 1 to b. But it leaves the x's alone. So if I have this one, b to the x, and then minus 1, it's going to subtract 1 from y. So it's going to be 1 minus y, which is 0, and 1 minus b, which is b minus 1. Okay? Another one here, if I have b to the x minus 2, now the x's are being changed, and it's going to add 2 to the x. So it's going to add 2 to 0, so it's 2 comma 1, and it's going to add 2 to 1, so it's going to be 3 comma b. And on this one, b to the x plus 2 is going to subtract 2 from x, so it's going to be negative 2 plus 1, and it's going to be negative 1 plus b. So looking at these problems here, so for this one, 3 to the x, that's our parent function, right? So if I now say 3 to the x minus 4, so remember here I'm going to have my key points are going to be 0, 1, and 1, 3, right? So now if I do this x minus 4, then that means the x values are going to increase by 4. So I'm going to have 4 comma 1 and add 4 to x again, and it's going to be 5 comma 3. So those 2 points, and knowing that it's an increasing function, are all I need to know to be able to graph my new equation. Okay? So let's look at this. So the natural log function. So on your calculators, there's a button, the E button, and this is called the Euler button, E-U-L-E-R. And Euler's number is another irrational number similar to pi, but it's the unknown pi. And it is the value 2.71828. And you can actually put that in your calculator and see. And all we're going to talk about here is that this equation approximates the Euler function. It is an exponential value, and what we find over here is that as x grows to infinity, or as n grows to infinity, that we're going to get closer and closer to this Euler value, which is 2.71828. And you could put that in your calculator and test it, but we're not going to focus on that right now. Okay, so then our last problem is dealing with an example. So here we have a cup of coffee that's heated to 160 degrees, and it's sitting in a room that's 70 degrees Fahrenheit. and the temperature of the coffee is going to decrease at this rate. So this formula they're giving you tells you what the temperature will be after 1 minute and after 2 minutes and after 3 minutes. So the question wants to know what's the temperature of the coffee after 20 minutes. So we're going to substitute 20 in for T, and we're going to put this in our calculator. Now when we put it in our calculator, we're going to put in the 70 plus 90, and then we're going to do the E, which is right above the divide symbol, raised to the negative 0.0485 times 20. And when we do that, we get 104.1. So it says round it to the nearest degree, so it would be 104 degrees. Okay, now the next part, and this is what we're going to be getting into more, is how to solve these without a graphing calculator. But right now I'm saying using a graphing utility, figure out when the coffee will reach 90 degrees. So what I want you to do is go to your calculators. You're going to go to y equals. And in your calculator, notice in y1 I put the 70 plus 90e and I put the formula. And in the second equation I put 90. So 90 is the temperature that we are going for. We're trying to figure out. So then I have to worry about my window. So remember in this, y is talking about the temperature of the coffee. Okay, so the temperature of the coffee is going to go from 0 to 160. Now in reality, it's actually going to go from 70 to 160. So do you agree that the temperature, if the room and the temperature is 70, the coffee probably won't get below 70. Okay, so we could change that to 70, but I'm going to leave it right now. The time is your X value, right? So I'm making an assumption that more than likely the coffee has cooled to room temperature within an hour. That could be less. So what we're going to do is we're going to look at our graph now. So what we have here is the temperature of the coffee. So it starts at 160 degrees and it starts cooling down, and right about in here is 70 where it starts evening out. It is an exponential function. It is decreasing, okay? This line that you see here is the 90, right? That's our goal. So we want to know, when does this exponential graph reach 90 degrees? So we're going to look for the intersection. So second trace, 5 is intersect, and then we're going to press enter until we get to that intersection point, and you'll notice it comes up with 31 for X. So at 31 minutes, or 31.01 minutes, your coffee will be exactly 90 degrees. Okay? If you look at the table, you'll notice in the table, and I'm going to skip down to 31 minutes. Okay? So you'll notice in the table, so that's when it got to be 90, and then it's slowly going to 89, 82, and we could keep arrowing down until we see that our coffee after 60 and 70 minutes gets to 73 and 72, but it really is never going to get below that 70. You know, we're looking here at an hour and a half and it's at 70 degrees. It's not really going to go below the 70. 70 is basically our asymptote. So that means that it's never going to go past 70. It's just going to get closer and closer to 70 degrees. So that just sort of proves to us that we're going to have that asymptote at y equals 70. Hope this helps.